Good morning, good afternoon, or good evening, according to your time zone. I welcome you to this third lecture of the online training series, Observing Marine Ecosystem Structure and Function, from Microbial Communities to Fisheries and Human Health. This is the virtual component of the in-person training course going to be held in India at the end of October, preceding the TREVOR Symposium. Apart from the students going to attend the in-person course, this series is open to the whole marine research community and especially encouraged our students and early career professionals. So we're very glad to have such a large audience today. A reminder that this is a lecture, so please take advantage of the knowledge of our speaker and the panelists and ask all the questions you want. Please post them on the Q&A box and we'll get to them after the talk. So now, before introducing our speaker, we have also a panel that will contribute to the discussion and is composed by Dr. Sebastian Krieger, Senior Data Management and Professional and Data Engineer from Bloomberg in Brazil. Dr. Bror Johnson from the University of New Hampshire, Dr. Lilian Krug, Scientific Coordinator of POGO in Portugal, and Lika is also a collaborator at TPSF, and then Dr. Shubha Sasiendrenath, a Senior Researcher at the Plymouth Marine Laboratory, and our alma mater at TPSF. And so now it's my pleasure to introduce our speaker today, Dr. Benjamin Loveday. Ben is a physical oceanographer with a background in marine earth observation and numerical modeling. He completed his PhD on Western Boundary Current Dynamics at the University of Cape Town prior to joining the remote sensing group at Plymouth Marine Laboratory. He now lives and works in Germany, where he provides marine training services to EUMETSAT. Ben has worked across a broad spectrum of EO applications spanning from ocean color, altimetry, thermal radiometry, and SAR, and has extensive experience helping users to understand the data landscape and develop corresponding workflows. So I think that will be very helpful. So his lecture today will be about satellite data repositories and access. Ben, the floor is yours.
Thank you very much, Vivian, for the introduction, and to the TPSF Organising Committee for the opportunity to be here today. One thing I would say from my introduction is that I believe in a really practical approach to the subject that I'm going to cover. So as part of webinar 3 on satellite data access, we're going to cut things in two. And for the first half, I'm mostly going to give you an overview of where I see the data landscape and data access landscape going and how you navigate it. And for the second part, we're actually going to give some practical demonstrations and some walkthroughs, some of the actual platforms that I think are going to be most relevant for you as predominantly ocean color researchers, but also I will refer to other variables and other places where you can get data as well. So at the very end of here, I'm going to walk you through very briefly different ways of accessing 6 different platforms, and that will comprise the second half of my presentation. As Vivian said in the introduction, my job at the moment is I run a contract on behalf of EUMETSAT called the Copernicus Marine Training Service, which means it's my job to help people work with marine data from Sentinel-3 and Sentinel-6. So if you've ever got any questions about EUMETSAT marine ocean color data from Sentinel-3 AltSheet, chances are your questions will come to me. So bear that in mind. And please place all your questions in the Q&A. Let's try and make the panel discussion at the end as robust as we can, because we've got an hour to discuss your concerns around data access and how to successfully navigate the variety of services, platforms, and access methods that are available to you as users. So let me share my presentation. Hopefully, can someone just give me a nod if you can see that okay, just to make sure? Fantastic. Yes. Okay, so let's make a start. So we're going to spend the first half an hour talking about data. So not just how you access it, but also how you should maybe begin to start to think about how you should choose what data you want. Okay. I'm going to divide that into three parts, really. The first part is going to talk about the data landscape. What data are relevant to us? What satellite missions are there? Sensors? What does satellite levels even mean? I know this is something that's been touched on as part of the earlier presentations, but I'll probably give another brief overview of the different levels of satellite data that are available, and how you select that data. Then we'll move on to the second part, which is data providers. Who has the data you want? Are they agencies, different repositories, downstream integrators of the data? What sort of scales do they deliver data at, and what are their interfaces? And the last part we'll do a demonstration of some of these interfaces, basically the tools, approaches, platforms, and demos for some of the services that deliver the data you want. So part one, what data are relevant to us? And when we're doing any analysis, any piece of research, or any kind of data discovery, or proposing any scientific question, we usually start with our first question of what data do I want? And often there are a couple of things we think we know when we ask this question. Sometimes we know them fairly clearly. Sometimes we think we know them, but there is a degree of subtlety we need to consider when asking the question. We usually think we know what variables we want, what fundamental qualities are we looking to measure, what do we need to underpin our analysis. And we usually think we know what area and time period we want to cover, especially if we're looking at a specific event, or we're looking at something climatic or longer term, where we might want to look at maybe a more global perspective. But as with satellite data, oops, sorry, I've just got a little toolbox thing. I'm trying to move out the way for me. There are a number of other things we want to take into consideration that really will frame how we ask that question. First of all, up front, we need to be really, really clear about our ask of data, because it is huge. Earth observation data is really, really massive. Secondly, it's nearly always not in the same place. We are very lucky if we can find a centralized repository that provides all of the information that we need to satisfy all of the questions we want to ask around our question. So we usually have to go shopping for a number of different repositories to look for all the components of our analysis. And the third part is acquisition, download of the said data, given its size, given its complexity, can be really, really time consuming, especially if we're operating in places where bandwidth is limited. So it's good to get it right first time if we can. When we ask that question about what data we want and we think we know the variables, there is a lot of subtlety behind that ask. There are a number of different components or different angles to that question that we need to think about in order to answer that question maybe more fully. And here is a non-exhaustive list of some of the things we might want to consider when we're asking ourselves, what is it I actually want to get from my data to look at a specific phenomena or a specific event? Firstly, relatively obviously, spatial coverage. Does the satellite even cover my area? Not all satellites acquire globally. Those that are in geostationary orbit, for example, always view the same disk, the same view of the Earth. Those that are in low Earth observation orbit generally have polar orbits, but don't always sample everywhere on the ground. For example, they might not sample the polar regions, they might not sample the open ocean, for example. So we need to make sure that the actual fundamental data record we're looking at contains the coverage that we need. Do we have sufficient spatial resolution to answer the question? Are we looking at somewhere that's highly coastally constrained, for example? Are we looking at a very, very finely detailed phenomena that we can only see with the highest possible spatial resolution? Given that spatial resolution, do we have the necessary spectral resolution to answer the question that we want? We might be able to look at data sets that give us extremely detailed pictures down to the centimeter scale from commercial data holdings, but they have nowhere near the spectral resolution we would require to be able to derive any useful ocean color properties from them. So essentially, they're just images. We can't do anything quantitative. Are the algorithms that we are looking at suitable for our needs? Chlorophyll can be derived through a number of different algorithms, and they are very often not equal and often specific for a single purpose. Are you sure that the one that's available in the data set you're looking at is the right one for your needs? Then we look at the time base. How often is your region sampled? Is a 7-day or a 21-day revisit enough for you? Do you actually need data to be specific to a single point in time, or is a daily or an 8-daily aggregate enough? And lastly, how long does your time span need to be? Are you looking at a phenomena that lasts an order of days or even hours, or are you looking at exploring something that has happened or changed over the last 30 years? All of these are questions you need to be able to answer or potentially answer before you go shopping for your data. You also want to consider quality. Is the data near real time? Or do you need it to be near real time to monitor something that's ongoing? Or do you want something that's higher quality and has been reprocessed or even or produced as a climate data record, give you the highest quality versus the sacrifice of that availability in the last few hours? Data is nearly always lost. How much of it is lost? Is it really lost? Can you recover it under the flags? Or are the flagging regime, and a flag is something you would usually implement to remove data that's poor quality, but maybe a flag will also cost you data that you need. And there's a few other things you might want to consider as well about how often or how well you can use data in the context of other sensors to pull things together synergistically. Is the format something you can easily work with, or is it proprietary? And lastly, but not insignificantly, are you allowed to use it? Is the license free and open? So there's a whole raft of questions you should answer before you go embarking on what could potentially be a very long download process before you, which might not be suitable for your needs. And you have to answer all these questions really, and much of what you want to derive from your data, or many of these questions are in part determined by the level of the data you can or you need to use. And I'm going to spend a little bit of time on a short aside to describe what we mean when we talk about levels in satellite data. And I'm going to break it into 5 levels. And each one of these levels gets, I would argue, less complicated to work with the further down the chain you go. And I'll come to that point again in a couple of minutes. So when we talk about satellite data, the first data level we have is level 0. This essentially is data that is taken off the sensors themselves and converted from raw voltages and currents into units that are useful for engineers and for those working on sensor calibration, for example. And in general, this data is not distributed to the community because nobody other than the specific engineers who work with those sensors is able to use it. So that is data that sits at the operational satellite agencies such as EUMETSAT ourselves, and we don't give it out to the community. Once we've reconstructed that into a top of atmosphere signal, this is where we get to level 1A, level 1B, and level 1C. We've usually gridded that into something useful spatially so that you can choose a region or an area or even a pixel that might be of interest to you with a given latitude and longitude. And we've added some time references and annotated it with any ancillary information you might need or any extra information you might need that describes the conditions in which the measurements were made. This is the first level at which you would really want to work with the data, but it is also the most technically complex. And the only reason you would want to go back up to this, or one of the primary reasons, is if none of the data levels below this are suitable for your purposes. And I can give you an example at the end. When we get to level 2 data, in general, we've removed the atmosphere. We've corrected for all kinds of effects, either absorption due to aerosols or the effect of the absorption of water vapor. And the atmospheric correction we apply is usually related to the kind of sensor we have and the kind of measurement we are making. But usually when you get level 2 data, it's mostly been corrected for all the interferences from the atmosphere that we typically want to remove when we're looking at an ocean signal. And we're left with these geophysical variables that make sense to us in terms of measurements on the ground. And this is where we get our chlorophyll concentration, our sea surface temperature, our significant wave height or sea surface height, for example. So this is where we really start to get to quantities that we can compare with what we would measure when we are sat on the ground and measuring with in situ data samples. Level 1 and level 2 data is usually or nearly always single mission. So this is what comes off one satellite platform. And one satellite often is not sufficient in order to see a full or the fullest possible picture of a given area or a given phenomenon. We usually want to merge satellites together to do this. And this is what we do at level 3. So we take data either from one or from lots of different satellites and we map it onto a uniform space-time grid. This allows us to increase the actual coverage of the data, but in general, it does cost us some spatial resolution and we have to make some compromises with the information that we can pull from different satellites as not all satellites have the same kinds of data, and we usually have to limit ourselves to the commonality between the two. If you think of this as a Venn diagram of different satellites, we can only usually make level 3 from what sits in the middle of this Venn diagram, so what is consistent from all the platforms that are available. Now, even when we do this and create these level 3 records, we don't fill the gaps. So we just take the actual measurements and we combine them together onto a uniform reference frame. And at level 4 is where we start to actually say, okay, fair enough, there was some cloud contamination here. What can we do to fill the gaps in the data so that we have a consistent gap-free record? And we can do this through a number of ways. We can do this by aggregating in time. So we go from, let's say, a 1-day product to an 8-day product. So we take a composite. We can do this using statistical methods. So we can use various approaches like empirical orthogonal functions, which sounds complicated, but really we're looking at the underlying statistics of the data and reconstructing what is missing. Or we can use machine learning based approaches to fill that in as well. And level 4 is the end of our kind of satellite tree, if you like, of our kind of tier of levels. And you could sort of map them all onto a two-dimensional axis, really, between convenience and flexibility, which is what I've done here. So on the bottom, you have the convenience of the data going from less convenient on the left-hand side to more convenient on the right. And on the y-axis, we have the flexibility. And by flexibility, I mean how able are you as users to craft this data to something specific that fits your purpose and your purpose alone. And I go from more flexible towards the bottom to less flexible towards the top. And I have to really describe what I mean maybe a bit more by flexibility here. You can see that as we go sort of across the levels, and the levels are noted in the black dots through the middle of the plot, we generally go from data that's less to more convenient. So it's easier for you to use, but more to less flexible. It's less convenient for you because all of the assumptions used to make that data set cannot be reversed. So they've already been baked into the final product, and so you have no choice but to accept the fundamental method that's been applied to that data as we move to higher and higher levels. So for level 4, for example, it's very convenient to use. There are no gaps in it, and it's already been consistently gridded, and it's usually available for a fairly long time period. However, you have no choice of the chlorophyll algorithm that's been applied. You really have no choice with regards to the atmospheric correction that's been used. You can rely heavily on the approaches that have been adopted by the producers of the level 4 data, but if it's not suitable for your purpose, then you're going to have to go further back up the tree. So that might bounce you then to go from level 4. Okay, maybe I look back at level 3 because I actually want to not get the statistical data. I only want to get the absolute and the sure measurements themselves. So you move back to level 3. But then you might find for your case that the atmospheric correction or any other corrective approach that's been required or been used to go from level 2 to level 3 is not suitable for you. Then you have to go further back up the tree again to level 2, etc., until you might find in some cases you need to go all the way back to the level 1 A or B data for your specific use case. And where you end up on this map determines where you might want to get your data from. And you can see here there are a number of different agencies and services and data providers listed in these little icons that give you some idea about who produces and who distributes the data in these different kind of paradigms. So we have undistributed level 0 in the red on the bottom left. Then we have the space agencies, EUMETSAT, ESA, NASA, NOAA, who tend to distribute these single mission products at level 1A and B and level 2. Then you have the downstream providers and services such as the Copernicus Marine Service and CCI, who have done a lot of the hard work for you in bringing together these single sensors data streams into multi-sensor records at level 3 and level 4. And then you have a load of other services that sit in the top right, which I'm just calling third party, which tend to be more images and maps that are distributed by web map service systems or other kind of geophysical data portals that give you really a snapshot picture, but not data that you can typically manipulate for any sort of analysis. And they are the easiest to use, but you can do the least with them. So there's this kind of map of complexity, convenience, flexibility that describes kind of where you should go to get your data. So the second part, who has the data we actually want? And this is where we'll go into a bit more detail about the data sets themselves and who keeps them. The first section of the data market, if you like, the people who provide all the various holdings you might be interested in, are the satellite operators themselves. And here is a completely non-exhaustive list of organizations who develop data streams, launch missions, are engaged in satellite operations, do the initial processing, and also provide the data at level 1 and level 2. And I imagine many of these look familiar to you, perhaps some don't. So we have EUMETSAT and ESA, two major distributors of marine data across Europe, as well as the French and German space agencies, CNES and DLR, to give some examples. In the US, we obviously have NASA, NOAA, but Landsat comes from USGS. In Asia, we have KIOS, JAXA, and ISRO, who also distribute data themselves. And in the commercial sphere, who deliver ever more data, and in some cases under license conditions that you can use quite freely. We have Planet, ICEYE, Digital Globe, and that is a landscape that's changing all the time as new use cases are developed, new businesses form, and new technologies get tested in space. It's a busy market. This slide may be, something like 10% of the available data providers at national or commercial level where you can go to get data. Downstream, you have a second set of people who provide data. These are programs and providers. So these tend to act as either platforms that bring lots of data together to use synergistically or in one place, or they are large-scale international programs that coordinate the production of data downstream at level 3 and level 4, and then distribute that data across consistent platforms. And under this bracket, I put things like the European Commission's or European Union's Copernicus program and associated Copernicus Marine Service, the ESA Climate Change Initiative or CCI initiative. There's the Destination Earth platform, which I will talk about again briefly later. There are coordination groups, such as the Group for High Resolution Sea Surface Temperature. There are individual research and data dissemination groups, for example, at Plymouth Marine Laboratory, at the Aviso Satellite Altimetry Center, and the EUMETSAT OCSAF. There are commercial aggregators, if you like, in AWS and Google Earth. And there are also other ancillary to Ocean Color, at least, data providers in ECMWF for all your atmospheric variables, and to name just a few of the ones that are available out there. And these tend to pull lots of different data sources together and/or deliver downstream derived products that are a little bit more specific than what you might get from a generalized kind of platform portfolio. Now, I'm going to focus on one of these very briefly for my second aside, and that's just to focus a bit on the Copernicus program, because the Copernicus, which is the European Union's Eyes on the Earth, they call it, but it's the European Union's Earth observation program, brings together lots of data, including significant amounts of ocean color data from multiple different sensors and sources, and combines it under these three different pillars of activity. Now, on the left-hand side, we have the space pillar, and this is where EUMETSAT and ESA work to provide marine data at level 1 and level 2. And you can see I've highlighted in some of the orange boxes, maybe the important parts of this diagram, and you can see where different satellites are operated by different people, and then the data that they contribute to the community, either through delivery directly or through delivery by downstream services. So, for example, EUMETSAT are responsible for providing, to give this notion color flavor, the marine data stream from Sentinel-3 AltSheet. So all processing for Sentinel-3 AltSheet and the marine theme comes from EUMETSAT and is contributed to users directly, but also downstream into the Copernicus services, which I'll come to in a minute. The land side of Sentinel-3, including Sentinel-3 AltSheet, is processed by ESA, And so that again is contributed downstream into Copernicus services. So wherever you find Sentinel-3 Algae lands data, it will have been primarily processed by ESA. And whenever you find Sentinel-3 marine data from Algae, SLSTR, and SRAL, that's the ocean color, thermal radiometer, and altimeter on Sentinel-3, they come from EUMETSAT. But there's also a load of other data you might be familiar with in there. For example, Sentinel-2 is processed by ESA for land and is contributed downstream. And you should be able to find most of the missions, either current or foreseen in the next few years, listed, at least under the Copernicus program, listed on that on those two columns. Those then enter the level 3 and level 4 kind of production suites and services, if you like, downstream. So the most appropriate for this discussion is the Copernicus Marine Service. That is coordinated by Mercator Océan in Toulouse. And that is one of your main go-to places for level 3 and level 4 ocean color data downstream. Excuse me. And many of those products contain inputs from upstream missions like Sentinel-3, Algae, MODIS, PACE, SOON, VEERS, CWIFs. So they tend to integrate lots of different data streams from different places to make level 3 and level 4 records. And I'll give you a bit of a walk through some of the parts or some of the catalog that's available there as well. And as you can see, there are 6 different services there providing thematic data for specific purposes. And the third part of the Copernicus program, which often gets not the credit it deserves, I think, is the in situ component coordinated by the European Environment Agency. Lots and lots of in situ data is coordinated, collected under programs such as EMODNet, and then contributed to the Copernicus Marine Service. And this forms the third kind of component, if you like, alongside the satellite records and models that makes the Marine Service a really powerful place to go for oceanographic data for lots of different purposes. Okay, so that should give you an idea about the players who maybe are in the arena, if you like, in terms of data access, the people who actually have the data holdings you might want. What sort of services do they have and how do they deliver their data? And the answer is it's very complicated. Nearly always you can find data sets in multiple different places, and nearly always you can find that data accessible through lots of different methodologies and lots of different services, if you like. To give EUMETSAT as an example, and here I've listed 7 or 8 different kind of tiles with each detailing how you can access data from them. EUMETSAT deliver data through our data store. This has a web GUI, so a graphical front end, or via API. You can access data through our data center. If you have a EUMETCAST dish, which is a satellite data distribution system, then you can receive it through that. And you can also view data through our EUMETView system, which is a web map service for showing images like I discussed before. Similarly, the Copernicus Marine Service have a web GUI or a graphical front end, access to a browser and APIs. NASA have Earth data, which also has a GUI and an API. The European Space Agency has the Copernicus Data Access Ecosystem, Data Space Ecosystem, I should say, CDSE, as well as the CCI Open Data Portal. There is the Wekio DIAS for Copernicus, which acts as a downstream integrator, also has a GUI and an API. And then they have the NOAA Coastwatch Data Portal, who's has a reduced data holding, I would say, at the moment, but that can be accessed through WebGIS and API as well. I'm going to give you examples of most of these, so you don't need to worry too much. The point of this slide is just to show you that once you've isolated who has your data, trying to find the methodology by which you retrieve that data can still be relatively complicated. And usually, there are multiple different ways in which you can choose to access it, and you should choose the one that is most convenient to you. Beyond those, we also have the ones I've listed on the right-hand side, where you have specific portals geared towards certain data holdings. I won't be focusing on those quite so much in this presentation, but it's good to know that they're there. So here is my quick overview who has it for some of the most likely data sources for what you will probably need. Again, this is nowhere near comprehensive, as it would be impossible to make a diagram that covered all aspects of the data access landscape, if you like. And for the sake of our presentation today, given its relevance, I think we should focus on the ocean color column the most. And that will give you an idea mainly of your first points of call for some of the places you should go to get the data you need once you know what data is available. So to give you an example, for ocean color data at level 1, we have for AltG the EUMETSAT data store, which is also available through Wekio as EUMETSAT feed it directly. For PACE, MODIS, and VIIRS, you can retrieve this through NASA Earth data. And for Sentinel-2 MSI, you can get this through the ESA CDSE. For level 2, again, you can go to roughly a similar set of providers, except you can get VIIRS products now through NOAA. Note that there is no Sentinel-2 MSI data at level 2. There is a marine-specific dataset in production, but at the moment, the Sentinel-2 data that you find in the wild, and that's the stuff that's on Google Earth Engine, on AWS, and also in the CDSE, is mostly suitable for land and not really for retrievals in water. So you'd have to do your own processing from level 1. Level 3, we have then the Copernicus Marine Data Store, where we have all the Copernicus marine records. Again, the Wekio platform, which also holds everything from the Copernicus Marine Service and the ESA CCI Open Data Portal, and a similar story for the level 4 products as well. So if you come at this question with no idea about where you should start to look for the data you need, this should give you a first point of call for many of the questions you may have related to where you should start. And I'm not going to go through all the other columns, but feel free to ask me questions in the Q&A at the end if you have anything specific you want to know. Okay, my third aside in this presentation component, things to be aware of when you go shopping for data. And these are more things to bear in mind when you're looking. Who has what is not always well advertised. You might find that data holdings exist, but they're not always documented so well, or they are missing a bit in terms of data discovery or are poorly described. This is something that is improving greatly across the entire data landscape as we all work towards kind of co-discovery of different data sets, but it's not 100% coverage at the moment. Sometimes the collections and the products are not always 100% described. So do some testing first, make sure you're actually getting what you think you get. I would highly advise that you avoid using data you find on a random AWS S3 bucket. Just because it's convenient doesn't mean you should use it. It might be stuff that people have put there that's their own test case data and it's poorly documented. So take care when you're using stuff that appears to have no traceability, no metadata, no information associated with it. And the third thing to bear in mind is there is replication, and that replication is not always transparent. Some cloud services will take data without asking the initial provider about the nature of that data and how they support it. So always ask questions of the provider of the data. Where did you get it from? Can you support this data? Because you might find that if you can't ask questions to the provider that are related to the data set, maybe they're not the best place for you to go to get the data. The second thing to note, and I'll come to this again in a little bit, is formats are starting to change. In the past, we had generally quite proprietary formats. Every mission had its own individual kind of approach to data distribution. We've mostly harmonized and settled now on the use of NetCDF in the current paradigm, but in the future, that is almost certainly going to change to use more cloud-optimized formats, such as cloud-optimized GeoTIFF or ZAR, because they allow us to work with data in more effective, more efficient, and more creative ways. So be on the lookout for these changes, which may well come quite soon across quite some large catalogs, to see if there are ways that these new formats can better support your activities, your workflows. And the last thing I would say is that storage architecture is also starting to change to underpin this new paradigm we have of cloud optimization. We are generally moving away from what we call historically block storage into more object storage architecture. And this is things like S3 buckets, and they are discoverable often now through new ways of cataloging data, such as the spatiotemporal asset catalog or STAC. All this means is we are starting to move away from paradigms where we download data into something where we support discovery and more flexible access and use. And I'll happily answer any questions you have on this in the Q&A. So, part 3, how do we actually get the data we want? And I'm going to give what is very much my perspective of how things have changed in the last 20 years and looking ahead, probably realistically, to the next 5. In the past, moving files was our only option. We had offline archives, sometimes delivery through hard drives themselves, sometimes only block storage of data, proprietary formats. You had no choice but to work locally, and you had a list of services that were limited in terms of the flexibility they could provide. Things such as FTP, you have no choice but to get whole files. You can't regionally subset. Search is difficult because it's only on file name, etc. In the present, we've moved from kind of data to a data through services paradigm. We've changed the way we store data. We've settled largely on how we format it, and we have a whole raft of services that better support workflows that are more targeted to how you actually get the things you actually want. You don't have to get just a global slice anymore. You can choose to get just specific regions you might want to pull out. And there's a big move away from the early kind of formats and protocols we used into the use of APIs. So writing smart queries that go and get the data for you. And we have STAC as well, which is improving how we actually discover the data itself. So it's a little bit more universally shareable and discoverable. The future largely represents a whole-scale paradigm shift. We're moving from, or we're ever increasing the volume of data that we hold. Every mission comes with usually increased spatial resolution, often increased temporal resolution, and often increased spectral resolution. Fundamentally, we can't realistically keep pace with sending this data around the world to support all workflows. So we're going to have to go the opposite direction. We have to move the process to the data. It is no longer feasible to move the data to the process. And this means that we have to find more effective ways of working. We introduced the idea of edge computing. So rather than downloading data and working on it locally, you send your process to the data itself, and it runs at the edge of the data archive and delivers you only what you need. We moved to cloud optimized formats, so you can perform remote extraction and remote analysis and only retrieve the data you want. And we start to have these federated data spaces, which broadly means that we tend to put things together in the same platform, in the same context, so that you can do multivariable analysis in a remote context. So my entire presentation, if you like, about downloading, largely, I would expect, will become irrelevant in 5 years, because we will have to completely flip the paradigm around and move what we want to do to the data to it, rather than move the data to us. This is my personal opinion, and it's probably lightly controversial because it won't work for all workflows. But broadly, if this is what I see in my job. Okay, so we're going to move on to the demonstration part now, I think, and we're going to look at 2 different ways of how you get data. We're going to look at web UIs. So web UI is just a browser-driven graphical front end that you can select data from by clicking on a web page. And we're going to look at APIs, atmospheric application programming interface, which is where we do code-based examples of data retrieval, which is much more appropriate for any process that you want to do a large number of times. You don't want to have to click around a website repeatedly if you're going to be doing something day to day, or you want to get a large amount of data. So in general, we say that web UIs are machine to human. So basically, they are designed to be interacted with by people. And the APIs machine to machine, they are designed to be interacted with via code. And here is where I'm going to give you 6 very, very short demos of 6 different ways that you can interact with data. And the ones that I've put in bold are broadly the ones that I'm going to show you. And I think I've got enough time to cover all 6. So we're going to cover the EUMETSAT data store through web UI and API, NASA Earth data again, through Web UI and API, the Copernicus Marine Copernicus Marine Service Data Store, again, the OCCCI webpage, only through the web, Wekio through the web, and lastly, the CDSE through the web, the Copernicus Data Space Ecosystem. So I'm going to stop my share because I'm going to have to share a different screen in order to do this and just give you a flavor of each one of these 6 platforms. And hopefully, if you watch back over the recording, then you can make a start with accessing data through any of these. So I will stop sharing and share my other window.
Ben,
Yes.
would this be a good point to ask if there are any burning questions before you move on to the demo?
Oh, happily, yeah. Whichever way you want to do it. I'm quite happy to answer questions.
It's just a thing I thought, but I
Sure, go
don't
ahead.
see that there is anything urgent in the Q&A. Maybe you need a pause anyway.
Thank you. I appreciate that.
There's one question only at the Q&A so far by Vanessa Cabucci. How are the in situ data organized and where do they come from? Do they include the in situ data from all the available and free to use Marine Data Center? Are the in situ data used to validate and improve the reanalysis products?
They come from a variety of sources. I can't give you an authoritative list. You'd have to consult the platform. It is not comprehensive. It does not contain all in situ data available for all purposes. Unfortunately, that's still a bit of personalized kind of shopping that you have to do to find the relevant validation data set for your own purpose. Whether or not they're included in either assimilation into or validation of reanalysis in particular is something I can't answer, but I have used them for some validation of my own workflows that are satellite focused as opposed to actual construction reanalysis. So you should find inside the Copernicus Marine Service for every single product there is a quality document, and that will tell you exactly how each product is validated. And it will give you a list of data sources that are used to do so. You'd have to cross-reference that with the in situ data that's in the platform. But I suspect that if it's used for validation regularly, that you'll find it inside the Marine Service as well. Sorry, it's not such a specific answer.
Oh, thank you.
The in situ data may also be available elsewhere. For example, the OCCCI in situ database goes to Pangea. It's an interesting point. Maybe we should put them along with the satellite data, but we don't. So NASA has their own platforms for their in situ database. So that's an altogether a different set of search and find.
Yeah, so as far as I'm aware, CBAS data is not in the Copernicus Marine Service, nor that from the OCDB, Ocean Color Database that EUMETSAT hold. And the CCI in situ data is not, and I don't think anything from Aeronet, for example, is either. So again, this is an exercise you would have to do individually to look for ocean color validation data from in situ sources.
There are a couple more questions I thought in the chat. To what depth can the satellite collect data? Ben,
Okay, so let's assume you're talking about ocean color because different sensors obviously can see different depths. For ocean color, it very much depends on where you are looking. We have this concept of optical depth. So if we're near the coast and we have highly turbid water, then the answer is not very far at all, of the order of millimeters. And if we are in the open ocean, in the gyre, in the center of the Pacific, for example, where we have not much active material in the water, so not much chlorophyll, not much turbidity, then it can be the order of 30, 40, maybe 50 meters, where we can still retrieve that signal. So it varies greatly depending on the optical constituents of the water.
Okay, thank you. There's another question here. Please don't, and I mean, before I read the question, a general request to all of you, please don't place your question inside a comment. We may miss that. So just place them as independent questions, okay? Anyway, Minu wants to know, besides CMEMS, which platforms offer long-term reanalysis data sets for marine biogeochemical variables, example, nutrients? World Ocean Atlas?
Yeah, I said the most obvious would be not for nutrients, but CCI. You might be
asking specifically about nutrients.
Perhaps there's some available through NOAA. Bro, do you want to answer? Yeah.
Yeah, the best source, if it's long-term reanalysis data set, not trends, but climatologists, the classic one is World Ocean Atlas, which has all nutrients, has nitrates, phosphates, and also oxygen. So World Ocean Atlas would be the best place to get long-term reanalysis data set for that are climatologists.
And Bror has also posted the link to CBAS in the response to Vanessa's question. And Harish says GLODAP. Harish, GLODAP gives nutrient data, does it? I'm not used that. Anyway, so there are options. So it's another question here. How can satellite ocean color separate phytoplankton from suspended sediments and colored dissolved organic matter? That was the topic of last week.
Exactly.
Yes,
I would suggest to watch the recording from last week and refrain here. And can I ask, so Brar, the World Ocean Atlas that I know, it's 1 degree resolution. Is it the same one?
Yeah, but they also have a database, so you can. It is mapped up to 1 degree resolution, but they also have the databases that they're using for the mapping under it. So it's probably
we can
the
have
best
access to that.
Yeah, exactly. So you can have access to that.
Okay, I think that is, we are up to date there.
Yeah.
Ben, are you ready? Okay to carry on now with the demos?
I am. Thanks very much.
Yes, thank you.
Okay. Okay, so can you see my website? I think you can, my screen.
Yes.
Okay, so the first place I'm going to look is the EUMETSAT data store, and you come here to get all level 1B and level 2 data from Sentinel-3 ALTRI. The data store can be found at data.eumetsat.int. I apologize if that's a bit small, but I can't make that part of my screen any bigger. And that will bring you to this page. And this page contains a list of tiles which give information on all EUMETSAT's data holdings, which is extensive. So the easiest way for you to then find the data you're interested in is just to type, for example, ALTRI into the search bar, and then you can peruse what is available underneath that search term. And you'll broadly find 2 different kinds of data. You'll find the level 1B top of atmosphere data and the level 2 ocean color data, where you have your chlorophyll estimate or your chlorophyll value. And there are 2 different kinds again in here, in that you can get data that's both operational. So this is the data that's updated in near real time, so every 3 hours, as well as these tags for data sets that are reprocessed, which is where we've gone back and revisited the entire mission and processed it all with the latest available operational processor, which is an activity we do every 2 years or so. I'm just going to select the level 2 ocean color full resolution product, and then this will just refine this down it'll add this as a search term, and it's the top hit here. So you can see ocean color, full resolution, Sentinel-3. And if I hit access data, this will open up a window where I can choose now to search in time and space the products that I'm interested in. I can use this AOI box here, for example, to make a little spatial filter. And I can also use this time box on the left-hand side to focus on, I'll just close that so you can view it, to filter by time. And now you can see that over this area, I have 4 products, all from Sentinel-3A, that match that time window. So quite simple. You do not need to log in to search for this data, but you do need to log in to download it. I'm already logged in as me up here. If you do not already have a EUMETSAT user portal account, then you can just click on login, and then it will give you the form where you can actually apply for an account. Again, completely free, but you do need to make sure you tick the Copernicus license box, and then you can download products from here, no problem. If you want more information on a specific product, you can click on the eye. It will open up a new window that will tell you a bit about it, including the components. You can choose to download only the individual components should you wish. You don't need to get the whole product. So you might only want, for example, the chlorophyll data that's available in the 2 different algorithms that we distribute as the standard product. Or you can choose to download by clicking the down icon here, which will download the entire product itself. That's all well and good if you want to get the 3 or 4, maybe up to 10 products. But if you want to search more regularly, if you want to do this in a batch approach, or you want to do it in an automated way that looks for and downloads the most up-to-date available near real-time product, then chances are you want to do this through a piece of code. And underneath the EUMETSAT data store are a suite of APIs, so application programming interfaces, that will allow you to search and download the data that matches these queries. And to make it a bit easier for you to do, we have this little icon here that says EUMDAC download command. And when I click on this, it will actually give you, if you have the EUMDAC tool, the command which you can download this specific product. And I'm going to show you a little bit about how you use this EUMDAC command now. So EUMDAC can be used for any product that's in the data store. It's not limited just to Sentinel-3 Ulchi, but here it gives you the syntax for how you would do that. And I'm going to show you a little bit about how that works. Before I go any further, I just point out that all information about our products is available through the EUMETSAT user portal, including information on Sentinel-3 Ulchi and including information on EUMDAC. So if I just type EUMDAC guide, because I know it in here, then now I have full instructions of how to use the tool that I'm about to show you. So you'll be able to find a load of different options for how to use it in here, all of which I don't really have time to cover in the short time I've got available. So I'm just going to give you one short demo for how to use this. So I'm going to show you very briefly from the command line. So here I just have a terminal. And I have the EUMDAC command installed using the instructions that are on the user guide. So I can just type EUMDAC. And here we go. It says, all right, it's installed. I have the tool. Now, what can you do with it? The first thing I'm going to do is I can do EUMDAC describe, and that will describe for me every single collection that's available in the EUMETSAT data store, which is relatively extensive. Now, I know the one that I'm after, so I'm just going to describe the one that I want. And you can get this information from the data store web UI. So you need to know the the code associated with it. Oh, sorry. Tell it the collection, and now it knows that this 0407 is the level 2 product that we were looking at before. Just to prove it to you, if I go back to here to the web UI, you can see 0407. This is my ID for the collection. So I can describe this product, and should I wish, I can also search for this product as well, or search for the individual, search the individual products under this collection. So let me just clear this actually. To give you an example, I can just put in the collection type here, so -C, the start and end dates, and I've defined a spatial box just because it makes it a little bit more pruned in terms of the search filtering, so you can see less fewer results for the search. It just tells me, oh, beware, you didn't specify a time, so fair enough. It's going to put it at midnight, and it returns me all 8 of those granules that match my search criteria. And if I want to download these, all I have to do is change the word search for download, and it will download all of those products in parallel. So it'll do 3 acquisitions in parallel, so it's not entirely sequential. So it's an efficient way of getting the data, and it maxes out the data delivery options that we have. The other way you can work with UMDAC is you can look via the Python implementation of UMDAC, and I'm very quickly going to show you that because again that's relatively powerful. Just before I do so, I would like to point out that we have a raft of training material on this site called UMetLab. If you type UMetLab into Google, it will be the top hit, and it will come to this page. Under UMetLab, we have a tag called Oceans and Ocean Training. And inside Ocean Training, we have loads of different options to help you work with the data that we have at UMetsat. If I click on sensors, for example, there's a specific repository for working with ALCHI data. And this will guide you through how you set up this repo, how you set up UMDAC to access data and the credentials that you need, and how you then work with all the products that are in the ALCHI portfolio. So if you want any training material on working with this data, it's all available here. And inside this repository, you will find an example called, oh, yeah, I'm trying to make this so you can read it better. Examples for how you get Copernicus Sentinel-3 ALCHI data from the data store, fully written in Python using UMDAC. And I'm not going to go all the way through this because I don't have time, but just to show you how it shows you how you authenticate the system and set up UMDAC, how you give it credentials, how you search for collections, how you then prune those searches based on various filtering options, and then eventually, towards the end, how you just decide to go and get the data that you're particularly interested in, either full product or a component of the product. So UMetsat data store for Sentinel-3 ALCHI Marine, either through Web UI, the UMDAC command line, or UMDAC in Python via the APIs. That's the first option I'm going to show you. The second option, if I just, sharing windows right in the way. Sorry, I've just got to move my Teams controls, is NASA Earth data. Historically, NASA have distributed most of their data through these things called DACs, the Data Access and Archive Centers, I think. And whilst the DACs are going to continue to do their work thematically for ocean color, for physical oceanography, for example, most of the data distribution is being centralized through the Earth data portal. So Earth data is now really your one-stop shop to get level 1 and level 2 ocean color data from PACE, OCI, VIIRS, and MODIS. And I'm at earthdata.nasa.gov, where you can get a list of data through the drop-down list, or you can, for example, just search for data that might be of interest to you. And we can refine by data set, and then we can load that on the Earth data portal. Alternatively, we can look through here. We can look through Earth data search, and we can launch the search. And we can see a spatial representation of all the data sets that we are interested in. This works largely similar to the UMetsat data store. You can type in the data type that you want up here, and then you can choose to specify your time and space boundaries, so you can refine your filtering and download through the portal. I encourage you to explore this. There is an enormous amount of data available in here as well. So it's going to take you maybe some time to find what you're interested in. But for example, if you just type PACE OCI in here, then we should prune the search results by the data types we're interested in. Excuse me. You should be able to find in this list somewhere. Perhaps I shouldn't have put OCI, but we can filter by platform or by instrument, probably better in this case. OCI. And we have 54 data sets that match our criteria. And this is all the PACE data at level 1, level 2, and at level 3 as well for some products as well. So I encourage you to explore Earth data too. All of this data is again accessible via API. NASA have a toolkit called Earth Access, which connects you directly to Earth data and will allow you to search within Earth data for the products you're interested in. Inside our training material, you will also find an Access PACE Earth Data option, which shows you again how to walk through accessing data via the Earth Access toolkit to download anything you may want from PACE OCI, including the biogeochemical, IOP, AOP products, and also the level 4 Moana phytoplankton functional type data as well. So there's an example here that shows you how to access all of these, acknowledging that you will need an Earth Data Cloud Access account to do so. That largely takes care of most of what I want to show you for level 1 and level 2, with one exception. The next portal that I think is useful for you to know about is the Copernicus Marine Service. For those that don't know, you can access this at marine.copernicus.eu, which will pop you up in this page. And the Marine Service data holdings are all level 3 and level 4, making them consistently gridded and therefore rather easier to search for and refine in terms of space at least. And you can access all the products via this Ocean Products tab. This will open an extensive roster of 300 or so products, and you can refine the search for all of these via either these tabs up here: blue ocean for general open ocean, physical oceanography variables, white ocean for anything that's more polar focused, and our interest, green ocean, for anything biogeochemical, and continue to focus even more, should you wish, by the variable you want, the area, and the source of the data. So in my instance, or my case, I'm going to choose satellite observations. And you can see we still have 53 records available. There is a huge amount of regionalization, a huge amount of different products available, different algorithms used to retrieve data in different circumstances for different areas. I'm just going to choose the first one on the list because it makes it a bit easier for me to do my demo. Excuse me. And here you can see we have a product which is the mass chlorophyll of concentration in seawater from the ACRI Glob Color product, which is a merge of the ocean color data from these sensors for the multi-products, and actually a 300-meter Sentinel-3A and 3B only product for the Ulchi. I believe this one is at 1 kilometer, and this 1 or 4, I can't actually, no, sorry, 4 kilometer, and the Ulchi is at 300 meter. You have a variety of options for how you access this data, and all of those can be accessed through this data access tab here. But what I think is the most powerful is this down arrow at the top here, because all of this data is now stored in a cloud optimized way as a ZAR format cube in the back end, if any of you who's used to working with ZAR data. And you can choose to either select the data on this map by drawing your area of interest, selecting your data ranges and choosing your variables, or you can choose to click this automate button, which will give you the Python API command to retrieve that data. So now we have just this pretty much drag and drop or copy and paste code snippet that will currently go away and retrieve this data set for you and download it as a subset. Be aware, this is still subject to some limitations on the amount of size of data you can request. So you have to be slightly careful. At the moment, I'm only selecting 1 day of data, but for example, if I put this one back to, let's say, this one might be a little bit tricky, but we'll see if we can do. Maybe I can go back. If I go back to the a month ago, for example, we're now looking at 13 gigabytes of data. We can't use to download this either directly or through the API because it's just too large to subset. But there are ways that we can cut it into individual days or individual years and download those slices. Once you have the data in that format as well, you can adapt this automate section for subset into a line called open dataset, and you can connect directly to that data and work with it streamed into memory. So you don't have to download data that you don't want. You only have to download the data that you request and are interested in, which makes it very powerful to work with if you're only looking at regional subsets through time. Once again, you will find an example of how to work with data like that inside our training material. We have this Access multi-sensor notebook, which tells you all about some of the data that is available for use and walks you through how to use the Copernicus Marine Toolbox to access that data and work with that data through Python. Next up, we have the ESA climate change portal, pretty much your other place to go for level 3 long time series climate quality ocean color data. If you go to climate.esa.int, it will bring you to the page that I'm at now. And if you click on the triple, or I don't know what you call this, hamburger or ellipsis or something, then it has a section called data, which will take you to the data holdings. And you can now search for what you're interested in, or you can scan down and search on the scan further down to see which data set you are most, or which data type, for example, you're most interested in. Clicking on ocean color will open a series of records, and each one of these records will give you information on the data set and show you the download options for how you might go about retrieving it. I should point out that for the Ocean Color Climate Change Initiative, so OCCCI, the options that you have available here through the ESA Climate Portal are not quite comprehensive, and you can get the same data from the oceancolor.org browser, which is developed and supported by Plymouth Marine Laboratory. And here you also have loads of other options for how you might acquire that data, and you can do so either via FTP or regional selection via protocols such as OpenDAP. So you might want to look at accessing the data you want from CCI either through the CCI portal, which will point you, I believe, to the CEDA archive, or through oceancolor.org browser, which might give you more flexible options for what you actually want to retrieve. Two more very briefly to cover. One of them is the WECIO DIAS. So the DIASs are the Copernicus Data Information and Access Systems, and WECIO is the one that's normally for marine. WECIO acts as a downstream integrator for the EUMETSAT data store and some products that are available from Sentinel-1 and Sentinel-2, and everything from the Copernicus Marine Service in one place. The nice part about the WECIO platform is it will also give you a Jupyter Hub, which is free for you to register for. And in that Jupyter Hub, you can work with the data next to the data. So if you're having problems downloading large amounts of data, or you want to work in a way that is semi-edge compute, so you don't have full resources available to you to do spin up your own virtual machines, for example. But if you only want to work in Python and you want to work with Jupyter notebooks, front ends, next to where the data live, then WECIO will offer you opportunities to do so. And on WECIO, we also have, under services and tools, we have a Jupyter notebook catalog. And inside this catalog, we have a load of training data from a load of different providers relevant to working with ocean color data and a whole raft of other data. If you look under marine, there are 112 examples in here for how you work with level 1 and level 2 data from Sentinel-3 and Sentinel-6, as well as from other platforms, all of which will immediately spin up in a Jupyter Hub environment and be ready for you to go without you having to download anything. It will take it directly from the cloud, put it in your workspace, and off you go. So you don't have to download. The last option I want to show you is the Copernicus Data Space Ecosystem, or the CDSE, because this is where you would naturally go to get data from Sentinel-1 and Sentinel-2 MSI. I'm going to just highlight the data tab here. Sorry, I should say this is available at dataspace.copernicus.eu. And you can see that you have data here from the Copernicus Sentinel missions and the services. I'll focus on the Sentinel-2 workflow. So I've just clicked the Copernicus missions there. And here I have information on Sentinel-2. And I believe in here I can also find the Explore Data button is what I'm looking for. The Explore Data button will open up the data and product kind of selection page. And I'll just be anonymous for now, though in order to download, you will need an account, again, free to register. And let's zoom in on an area. And hopefully we have something appear here, as it should do. I was doing so well. 5 out of 6. Okay, so there we go. Sorry, took a little bit of time to load up. And then we can choose to either view the images or the latest images on the fly on the platform, or download them too. So right now I'm looking at Sentinel-2. Let's look at the level 1C for the current date, and I can choose to apply a different band combination should I wish to the actual scene that I'm looking at. And then I can also move over to the search tab here, and I can refine my search via the products that I'm interested in, date ranges, etc. Let's just look at see if there's anything available from the last couple of days. There might not be because Sentinel-2 doesn't have a daily revisit. There we go, for example, though. And I can click on the tile that I'm interested in, and then I can choose to download the tile as well. The CDSE also has a load of APIs that underpin it. There are methodologies based around data discovery through Stack, as well as open data or OData, syntaxes and options for automated download as well. And as before, you can find examples in our training material for how to get Sentinel-2 MSI data from the CDSE. So there's 4 examples in here for you to explore if you wish. Ask me any questions about where to find this if it's ambiguous. And so that should be, I think, the 6 major places that I would consider as first points of call for all the data you might want. Level 1, level 2 from single mission, from MSI, from ALTSHE, from PACE, from Aqua, from VIIRS, and level 3, level 4 downstream from the Copernicus Marine Service and CCI, and Wekio as a unifier where you can bring lots of that data into scope with Jupyter Notebooks to support. I think that's the end of my demonstration.
Thank you, Ben. Thank you very much.